Hi everyone, this is the last set of writing our inverse trig functions in terms of u and v using the sum and difference formula. So if you're starting on this, you might want to start on some of the earlier ones that are a little easier than this one. First of all, we're going to let this be alpha and this is beta, and remember secant is 1 over cosine. So basically we're just going to have to flip our formula. We're going to let alpha equal inverse tan of u, and we're going to let beta equal cosine inverse of v. So tan of alpha equals u, where alpha is restricted between negative pi over 2 and pi over 2, and cosine of beta equals v, and our restriction is between 0 and pi. And our formula is just going to be 1 over, cosine of alpha plus beta equals cosine of alpha, cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. And since we're seeking secant, I'm just going to write this over 1. So this whole thing is over 1. Alright, so we have to find out cosine of alpha, cosine of beta, which we already have cosine of beta, sine of alpha, and sine of beta. Alright, that's beta. Alright, so let's get started. The first thing we're going to do is find secant. Secant squared of alpha is tan squared of alpha plus 1. So you square root both sides. We get secant of alpha equals tan is u, so that's going to be square root of u squared plus 1. Therefore, cosine of alpha equals 1 over square root of u squared plus 1. Alright? Now, sine of alpha is another one we need. We know is square root of 1 minus cosine squared of alpha. And we know that cosine of alpha from here is v. So all we're going to do is write this as square root of 1 minus 1 over u squared plus 1. Now to simplify that, you're going to cross, we did this in previous videos, this is going to be u squared plus 1 minus 1 over u squared plus 1, and you square root both sides, or both the numerator, because this cancels, over square root of u squared plus 1, and you get u over the square root of u squared plus 1. Alright, next we have to get the beta. So sine of beta is the same kind of thing. It's going to be 1 minus cosine squared of beta, which equals square root of 1 minus b squared. Alright, now if we want to finish this up, we have everything we need. We need secant of alpha plus beta, which is actually 1 over cosine of alpha plus beta. So, the thing I need is, let me write it all out, 1 over cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. So, cosine of alpha, we figured as 1 over square root of u squared plus 1, and then cosine of beta, it was v, and sine of alpha equals u over square root of u squared plus 1, and this was sine of alpha, and sine of beta equals the square root of 1 minus b squared. So let's fill it all in. What we're going to get is 1 over over square root of u squared plus 1 times v minus u over square root of u squared plus 1 times the square root of 1 minus v squared. And hopefully you're writing all this down. Now let's go ahead and combine with our common denominator. So get 1 over v times the square root of u squared plus 1 minus u times the square root of 1 minus v squared over square root of u squared plus 1. So I'm just kind of cleaning it up. Now, what I can do is, just from algebra skills, is move him up on the top here. That's just division. So I'm going to get, and they're the same, so that's just going to be square root of u squared plus 1 over v minus u times the square root of 1 minus v squared. And that's your final answer. Okay? And the reason I can do this part right here is because 1 divided by, and I'm going to call all of this, say, a complex number here. So this would be the a part and this would be the b part, is the same as 1 divided by a over b is the same as 1 times b over a. So this will get multiplied, the b part gets multiplied by the 1. All right, thank you. Have a nice day. Bye-bye.